Jim Collison, we're live here again at the Heartland Developer Conference in Omaha 2015. I'm here with Matthew Renze. And Matthew, thanks for taking a few minutes to be with us.
Thank you for having me.
Appreciate it. Your session, you have a session coming. Actually, you have two sessions with us. Before we dive into one of those, and maybe a little bit of both, tell me a little bit about where you're from, what you do, the vitals, so people kind of get to know you a little bit.
Well, I'm an independent software consultant with over 15 years of professional experience building large-scale, data-driven desktop server, web, and cloud-based applications. I have double degrees in computer science and philosophy with a minor in economics, and my focus was on artificial intelligence and machine learning at Iowa State University. And I'm also a regular public speaker, and I've worked on a couple of pretty cool open source software projects, and I'm also just recently became a Pluralsight author.
Oh, how's that going for you?
So far, so good.
How many sessions do you have out there?
I'm working on my first course right now, which coincidentally is exploratory data analysis with R, which is one of the sessions I'm doing today.
Yeah. So let's talk about that, because that's one of your sessions when we talk about we get all this data. We got to do analytics on it. R has been something at Gallup we have been talking about and using for quite a while now, but it is kind of making its way into the scene, right? And so we think, from your session, what are you hoping to get? I mean, what are you hoping people walk away with when you come out of your session?
Well, I'm targeting it towards the average developer who's interested in, who's working with data on a day-to-day basis and interested in learning how to leverage that information and transform it into like valuable insights. So by using R, which is a statistical programming language, we're hoping that they'll use that kind of on the side, not as their primary programming language, but use it to do a bit of exploratory data analysis, learn about their software, learn about the data that they have, and hopefully help decision makers make decisions based upon data. Yeah,
there's been a lot of promises of data analytics over the years, and I'm not close enough to it today to say whether we're doing it right or we're not. Are we doing it right or aren't we?
Well, it's to my understanding that, we have more data than we know what to do with. So in our current data-driven economy, the scarce resource is actually people with the skills and knowledge in order to transform that data into valuable insight. And so what we're hoping is that with educational sessions like this, we'll be able to teach software developers how to transform data into knowledge and thus make it valuable.
Yeah, well, okay, so it's easy to say, transforming data into knowledge. Way harder to do. Over the last years, we've made big advancements in hardware that's made that more possible to get done. But where are we doing it right from that standpoint? What's working really well in that area right now?
Well, I think the key right now is education. So we've got people that are data scientists, and these are kind of these mythical unicorns that, we don't even know who they are, what they look like, or where they really exist, because it's such a new kind of profession. In fact, there's even debates as to whether they should be called data scientists or not, because it doesn't follow the traditional scientific method.
Right.
So I think the education is the key component. I mean, we have all sorts of tools and stuff available, but most people don't know how to use them yet. So by having a programming language like R, but not knowing how to use it, your data is not going to magically transform itself into anything. So I'm hoping, at least with what I'm doing, that I'll help to educate the general public on how to use tools to do exploratory data analysis. And I really think we have to go all the way back down to school and teach like young children how to interpret, read, and transform data as well, so that when they get into the profession, a decade from now, they'll actually be viable.
So can I teach that to junior high? And
I think so. In fact, my belief in it is such that I actually created an open source data explorer. It's kind of like a piece of software that allows you to just load up simple data files and then kind of explore the data, almost play with the data in kind of highly interactive and engaging ways. And my intention was that I was hoping that students would start using it. I actually found that some graduate students at Iowa State University started using it. And then I didn't really think it would take off in the business landscape, but it was kind of my hope as well. So I'm hoping that tools like this will essentially make it easier to learn how to transform data and to understand it.
I'm fascinated by it. We at Gallup run a high school internship program, and we've begun, when I started with Gallup, we started working with master's level students, and then we thought, well, let's go back and see if we can get undergrad. And then they challenged me, could you do this with high school kids? And we're actually thinking about now, how do we do this with junior high students? So in our case, we're interested in getting them excited about object-oriented or software development, traditional software development in that sense. What I'm finding, just last night, we had a parents' night for our high school program, which starts in September. And they, one of the kids says, I'm a sophomore at this high school here in Omaha, and I've written 9 iPhone applications.
Wow, that's impressive.
I'm like, why? First, why? But second, like, that's really cool. It's interesting, though, as you say that, to think about we could push this. What is it about the science when we talk about R and those analytics? What are a few of the disciplines, or maybe even one of the disciplines, that kids aren't getting today that would help with that, as you see it from a data science standpoint?
Well, I think the first thing, at least from my perspective, is that it would be terribly boring to most students unless you could make it very engaging.
Yeah.
And so, like at Iowa State University, I go back every year and I judge they call it a computational thinking competition, where they have the students create little programs and then compete to see who had the most interesting problem solving. Or, there's a lot of things that they're gauging them on. But if we were doing the same kind of things with data, where we had these little data competitions, so that students could take a data source, something they're interested in, whether it be astronomy data sets or Pokemon trading card data sets, and then analyze the data so that it's something that's interesting, appealing, and understandable to them. Then they learn the techniques for working with data with something that's actually of interest.
Right.
Otherwise, this would just be terrible.
No, right on. We have found, in fact, we changed our program name from internship to innovation, because we want to focus on solving problems.
Yes.
Oh, and by the way, you might learn some code.
Yeah.
Right?
And that's how you have to do it.
No, that's
That's
interesting.
My niece right now is really interested in Minecraft.
Yeah.
And so I'm trying to get her interested in doing like little code modifications to Minecraft as a subtle way to get her interested in coding, but because she's so interested in Minecraft. Otherwise, she would never learn code.
Right on. And I think it's a subtle way of getting right out, well, I got to learn Python, or, I got to learn R in this case. Are you aware, so are there open data sets that are available? So if I was going to create an open data set and say, hey, come up, we need to solve some problems, where would you go for an open data set?
I use a lot of fun data sets from a lot of the universities have like their machine learning, like public data set repositories. Yeah. So I use stuff like movies databases. In fact, my presentation today uses the 2003 movies database, just something fun and interesting that everyone can relate to.
Right.
And it's not like, here's the statistical whatever data set that no one's going to care about.
Have you pulled any Twitter data or any?
Yes, I did a project that involved sentiment analysis, or latent sentiment analysis. It's called, where we look at certain words and whether they have a positive or negative connotation, and then determine whether the tweet overall had a positive sentiment or not, based upon those keywords.
Yeah, I think that'd be a good set to get too.
Yeah.
Twitter kind of limits that, but I think most people could get fresh, relevant data. And then, because I was just thinking about some junior high programs. So realistically, if I were going to start a junior high, we're saying 12, 13, and 14-year-olds, and I was going to have them get into R, to use R to help with that, what's the realistic setup for something like that? I mean, what could I expect? Or what would I expect?
I don't know that R would be the ideal platform to get young children started, because even as a programming language, I think most developers even find it difficult.
Okay.
It's based on a very old statistical programming language called S from Bell Labs back in 1976.
Right, yeah.
And so it has a lot of C-like programming constructs, but I think you would almost need a language that's better suited for children to get into. Like Python would probably be something that would be better.
Okay.
But I think even before that, getting them interested in interactive data visualization tools, so that they can kind of draw the data, to the screen and move sliders and faders to interactively engage with the data, would be the first step. And programming comes later down the road.
That's cool. No, this. I didn't expect to get into this conversation, but it lines up so nicely with what we're doing. In fact, we had our high schoolers do a session on Python 6 weeks of Python, and we in fact we called it the summer of Python. And just because, and so I am thinking, wow, we could back that up to junior high and have those junior high kids working on Python. In fact, the college student teaching the class talked how to write a Python script that mined Twitter. Right, that goes back and pulls stuff out. And interesting. Okay, huge rabbit trail, but let's bring it back to your session. Anything else from your session as we think about that, of things that if you want to get across in what you're talking about?
I think the big thing is that there's essentially a flood of data coming our way, whether people realize it or not. I mean, we're already waist deep in data, and it's growing exponentially every year.
Right.
And so in order to be viable in this new information economy, you're going to need skills in order to transform data into actual insight.
Right.
And so having skills and tools like working with R and having exploratory data analysis skills will essentially be a necessary set of skills in the IT world going on. So I think it's valuable in and of that.
No, very cool. From a industry adoption standpoint, when we think about big data, and I know it's moved on, Internet of Things is the cool word now, but we still got a lot of data out there. If you were to guess kind of a percentage of how much we're actually taking advantage of all the data we have out there? Have you thought through that?
I don't even know how to answer that. My guess is it's vastly less than what we will once we have the tools and knowledge in order to work with the property.
How far are we away from having that?
I think we're just, this is a tip
scratching the surface.
Yeah. The stuff that I see coming out every year, like the stuff most people probably don't know about in terms of what businesses are able to do with machine learning algorithms, is almost actually kind of scary. And I mean, we're really going to have to change the entire landscape and the way we think about how to use this data in order to integrate it within our society in a helpful and healthy way, I think.
Yeah. Before we turned on the record button, we were talking a little bit about some lighting and some motion sensing stuff. And I made a comment to you that I said, you know, pretty soon we're getting so granular in our data sets, especially when you think about control and lighting. So in a building like this, thousands of dollars a month goes into lighting this place, and it could be more efficient. But the data to get that almost requires machine learning. Doing any thinking around that?
Yeah, so
that piece?
The client that I currently work for, we do power over Ethernet based intelligent lighting control for LED lights. And so
can I say, what's the advantage of doing power over Ethernet versus just standard traditional Wi-Fi, like when we think of the lighting today?
Well, first off, it's the high voltage versus low voltage. So it doesn't require dealing with high voltage electricity anymore, which makes modifications to the infrastructure extremely easy. The install costs are cheaper. We're already running Cat5 cables through the building for the internet functionality anyways. And it's also, it gives you fine-grained sensing and control of every light and sensor in the building. It's a common web so that everything's working over the same like Cat5 cables. And you use your existing switching infrastructure, you move all that stuff back to the server room, and it's now an IT asset rather than an infrastructure.
That makes sense.
Yeah, there's quite a bit of value in it. And then once you have that fine-grained sensing and control of data, you can do things like apply machine learning algorithms in order to optimize the buildings for energy efficiency, do things like predictive maintenance, where you determine, well, statistically, this number of lights has gone out this year, so we're predicting that this number will go out. And based upon the way the telemetry we're getting from the light, this light here is probably going to go out sooner than everyone else. So there's a lot of very powerful things you can
do. There is. Is this, I mean, IBM's been talking about this kind of stuff for a long, is it the same thing?
Machine learning is a relatively general category. It's essentially a set of algorithms that do one of probably four main things, whether it's classifying something, doing numerical regression, or doing clustering, or some kind of prediction. And so essentially you can lump them all together, but there's new algorithms coming out all the time and vast improvements. For example, the recent developments in deep neural networks right now have just blown away the competition of the previous generation of algorithms in terms of their accuracy in predicting things, visual things, detecting like words and sounds, in addition to other things too. In fact, I read recently that the machine learning algorithms are now better than every human doctor on the planet at determining whether a brain tumor is cancerous or not, because it actually detects areas outside of the tumor itself, which are also very important in determining whether it's cancerous or not. So, I mean, it's going to be very interesting to see how these machine-assisted diagnostic tools, transform society.
And think about when we think about nanosensors, and getting into the body and being able to detect things and do their stuff and report back.
The internet of very tiny things.
For sure, and very helpful things from that standpoint. Going back to the lighting discussion, is LED I don't want to say the future because it's already here, but is it the end game from a lighting standpoint, or are there other technologies ahead of that will make it? Because LED is super efficient. I just installed a new light in my garage and put 4 batteries in it, and they're like, this will get 36,000 lights before you have to replace the batteries.
Well, I don't know if in terms of hardware, if there's something beyond LED. I'm sure they're working on all sorts of stuff. But what I do know is that even with LED lights in your building, you can still do things to vastly improve the energy efficiency, like using like ambient light sensing or daylight harvesting, as we call it, in addition to being able to detect motion in the building and optimize those motion detection algorithms, and also balancing rooms so that you're only using as much light in each area of the room as is necessary to meet a certain desktop light level.
And so, but to measure that, you have to have other sensors in the room that are measuring that as well. Is that a wash from a power standpoint?
I don't think so. Given the numbers I've seen, and I can't quote any of the numbers because I don't know the financials, but essentially it looks like there's a pretty big margin for improvement. So like significant.
Well, it's interesting. I think when we think about energy, we're trying to increase our batteries to get better. The equation though has changed. We're actually reducing the usage of them. Yeah. We're getting huge gains in them because we're reducing the way. I keep thinking, man, we can't get any more efficient, and yet they continue to figure out more and more and more ways to get efficient from that standpoint. So, no, a very cool discussion. When you look ahead 5, 6, maybe even 10 years, what do you get excited about? I mean, in your field, where you talked about the medical implication of this already, but what's that leading to? Are there things beyond that you're kind of like, man, I cannot wait till we get here?
Yeah, actually, there's a lot of things, probably more than I could enumerate in a reasonable amount of time.
Maybe pick one or two.
I think the most important thing for me is that what we see is that the productivity enhancing technology that we're creating actually enhances itself. So the rate at which we're increasing is actually growing exponentially rather than, a linear slope.
Yeah.
So essentially 5 years from now is going to look like more like 10 years ago in terms of difference, because it's continuously getting faster and faster. So that's very impressive.
But are we ever going to stop working so hard?
I don't know. At some point in time, our technology will surpass
in the 70s, we were like, oh, we're going to automate all this stuff and it's going to make our life so easy, and we're going to work 30-hour weeks, and we're going to, lap a luxury, and we are working harder. And listen, I'll be honest, I like working harder with some of this technology. I'll go out and work hard because there's so many things I could do.
Yeah.
I don't know if it's making me work less, but it is making me more productive.
Yeah. Well, the interesting thing is, we always predicted that we'd be working 30 or 20 hours or less. But what actually happened is everybody wanted to keep up with the Joneses. And so the amount that we spend is actually so much that we are actually forcing ourselves to have to work this much.
True.
We really, when you think about it, after we've met all of our basic needs, there's diminishing marginal return on each additional unit of happiness we buy with the money we have. So we probably could do a lot better with less if we wanted to.
We studied that at Gallup. That's actually in our well-being book. We have some numbers that say after this certain amount of money, it stops changing your happiness, which is really, really interesting. So it's interesting that you kind of quote that in there, because we believe that too. Although I think our quality has gotten a little bit better in that as well. So we're doing things. Go to Beijing today and look at the quality of the air. Go to New York City and look at the quality of the air. New York City was where Beijing was 40 years ago, 50 years ago. I think we are getting a little bit better, but it's certainly, I keep thinking, man, I work more hours, although I work more hours having more fun with some of the stuff than I've ever done. So, well, hey, thank you for taking a few minutes to do this very interesting discussion, and I appreciate your time.